Can you hear me well?
Yeah, please start your talk, Vladimir.
My name is Vladimir Katalov. I'm from Elcomsoft company, which is based in Moscow, Russia. We have about 25 people in our team, and for last 20 years, what we are doing is we deal with security of the applications, or more exactly, the encryption used in applications to encrypt the data. And so our products are about breaking those encryption and password recovery and password cracking. I won't tell about our software at all. This speech is only about some points of encryption in Apple iOS operating system and Apple iCloud. This is a kind of fresh statistics about the smartphone market. How much of those devices are using Android, iOS, Windows Phone, and BlackBerry. And a total of smartphones now is more than 1 billion, and it is expected that in 2 or maybe maximum 3 years, it will be more smartphones than people on Earth. And those devices contain a lot of mission-critical data, your private data. They used widely in the corporate environment, in government organizations, and so on. And there is basically all your life and many of your business inside it. And so there is a hard need for forensics, so to exploring the data stored on the smartphones and tablets. We'll concentrate only on Apple iOS devices. There are different methods to get the data out of the smartphones based on the operating system used there. There is a logical acquisition, which is simplest and fastest method, and which gets most of the information out of the device. There is also a physical acquisition, which is much harder to perform and sometimes requires the special hardware. There is a chip-off, that's the most advanced method, which requires you, it is destructive. You need to extract the memory chip out of the device and read it using the special hardware. And in many cases, you also need to decrypt this data, and it is not always possible. As you can see, you can perform the chip-off process for BlackBerry devices, but for Apple iOS operating system, it isn't possible because the encryption keys used to store the data, they are valid only in the context of running operating system. Most of the devices, they also create the backups of the data for your own safety and convenience. And those backups can be local on your computer, PC, or Mac, or Linux, or whatever. And Apple iOS devices, as well as Windows Phone devices, can also create a backup in the cloud as a built-in feature of the operating system. And you can also analyze those data. Next, most of the operating system can also store your own data, your documents in the cloud, about the same way as the backups are stored. And there is also a very good source of the information you can get. And finally, there is a location service for most of the devices, so you can get the exact location of the device right now. Speaking about the forensics about Apple devices, I'm sorry, it's probably the text is too small, but I will share the copy of this presentation. For the physical acquisition, it's not easy to perform. For iPhone 4 and older models, there was a publicly available boot ROM exploit that allowed you to upload your own code unsigned. Obviously, the Apple won't allow you to sign your exploitation code. And using Using those exploits, you can upload your own RAM disk right to the Apple device, and running in the kernel mode, you can perform the complete copy of the device right to the computer using that standard dd command. For more modern devices like Apple 4S and Apple 5 and Apple 5S and 5C, there is no boot ROM exploit, unfortunately. And the only way to perform the physical acquisition is to work with the jailbroken device, because it can run the unsigned code. If you cannot perform the physical acquisition, the next step you can perform is the, well, I should also say that for physical acquisition, the passcode protection implemented in the iOS actually doesn't matter. You can create a almost complete image of the device even without the knowledge of the passcode. And also you can perform the brute force or dictionary attack on the passcode. The only problem is that the passcode verification in iOS operating system, it is performed right on the device only. You cannot run the offline attack using the GPUs or supercomputer or FPGAs or whatever, and the speed of recovery is extremely low. It is only 4 or 5 passcodes per second. For iPhone 5, it is, I think, about 15 passcodes per second. So only simple 4 digits passcodes can be cracked. But as I said, the passcodes in iOS are used to encrypt only part of the information on the device for additional encryption. Without the passcode, you cannot get the mail stored in on the device, and also you cannot decrypt most of the data stored in the keychain. I will explain what is keychain and what it includes a bit later. Okay, well, if you cannot make the physical acquisition, the next step is logical acquisition. For iOS, you only need to perform the backup of the device. You can do that 2 ways. You can do that using the iTunes, or you can connect to the device directly and task the driver to perform that. The backup created by the device is actually contains a lot less information than you can get using the physical acquisition, but it is still quite a lot. It's all the call logs, it's all your messages, SMS and iMessage, that's your mail, your address book, of course, all the data stored by all the applications running on the device, your pictures, videos, music and so on. Oh, sorry, music is not included into the local backup. The next one is advanced logical acquisition. There is a way, and I will also talk about it a bit later, to connect to the device using the driver, which is working over the USB, and to connect to the service running on the iPhone all the times, and to extract some information out from there. Using that driver, using that service running on the iPhone, you can also perform the backup, but there are some commands to extract actually more information than available in the backup. And probably the most interesting stuff, you can get information from the iCloud. There is a way starting from iOS 5 to create not the local backups, but to upload backups to the Apple iCloud. It is actually much more convenient than creating the local backup, because you not always have your notebook or computer with you, and iCloud backup can be performed over the Wi-Fi, and it is incremental, so it doesn't upload all the information all the time, but only the changes since the last backup. And so if you lose your iPhone, or it is stolen or broken and so on, you can just go to the next shop, buy the new one, and restore your device in just a couple of hours. The first protection of the iOS device is the passcode. It is very easy to set and very easy to enter, and you can set up to the device to be unlocked right now, or it can be locked in 5 or 15 minutes after not usage. And there is also an encryption inside the iPhone. It doesn't depend whether you use the passcode or not, but the passcode is the most important and probably the most safe method of protecting your iPhone. As I said, for modern devices starting for iPhone 4S, if the device is not jailbroken and it is protected with the passcode, there is absolutely no way to get any information from there. There is also a special storage inside the iPhone, more exactly iOS operating system, called keychain. It is a kind of database which stores a lot of critical information like encryption keys, certificates, passwords to Wi-Fi access points you ever connected to, passwords to email, saved passwords from websites, and so quite a lot of information. And this keychain is encrypted also using the passcode. And so even if someone will be able to get everything from your device, but the keychain will be still encrypted if the passcode isn't known. And there are three types of the passcode. The simplest one is just 4 digits. Next, you can select the digits only, but any length. And the most safe one is alphanumeric of any length. But most people, of course, use the just 4 digits. It's not very convenient every time when you need to unlock your iPhone to enter a long sequence. Quick about iOS backups. According to Apple websites, the knowledge base articles, here is what it is, what kind of information is in the local or iCloud backup. It's obviously all contacts, that's your messages, call history, the data of all applications, of course, all of the settings of the device. The camera roll is all your pictures and videos, the software you bought, mail accounts, both set up, but not the cached mail itself, and network settings, and so on, much more actually. And to make a local backup, you just start the iTunes and select the device backup, and that's it. For iCloud, it is performed automatically once a day when your device is connected to the power source and to the Wi-Fi network, or you can force creating the backup yourself, pressing a button. Here is a simple program, right, actually in China, and it is quite cheap, at $15 or $20, which works with iTunes backups. They're encrypted also. It's not encrypted, but I would say obfuscated. You'll just get about a few thousand files with long generic names, and they're not readable. Many of them are SQLite databases. The other ones are plist files known to Mac users. And this program, among many others, shows all this information in a very convenient way, all the device type, model, number, whatever, and you can also browse your mails, messages, and everything. There is quite a lot of information which is not shown by those programs, and you cannot get it just by using iTunes. For example, all Apple applications, there are about 2 dozen of them, of course, save their own data in the device. And they're not visible, but you can get them by analyzing the backup. These are also mostly the SQLite databases. Also, you can get the data from the social networking applications and messengers like WhatsApp. From Facebook, Skype, you can get all the conversations from there. From the Foursquare, LinkedIn, Viber, and so on. And there is quite a lot of other data. For example, there are a few files on the iPhone which store the keyboard buffers in all languages you're using there, and by analyzing this text, you can see what that person, the owner of the device, actually typed anywhere in the browser, in messaging, in the mail, and so on. There is also the data from the passbook application, so you can see his, for example, boarding passes and so on. There is a database with the user's voicemail. There is a map data to track the locations where the person searched for some locations and visited them and so on. And there is also the database called LocationD. And I think that the file name is actually consolidated. You probably remember the scandal about Apple, about privacy, about 2 or 3 years ago, when it was found that iOS devices store most of the locations you ever visited and write them down into its own database. As Apple explained, that was done for faster searching for GSM and Wi-Fi networks, and those data were private, never sent to Apple, and so on. But still, this information is there. Also, from the backup, if you are smart enough, you can get the attachments for the messages, for MMS and messages and iMessage. And we have found that even if you delete the conversation, the attachments, the pictures, for example, or data cards attached to received or sent messages, they're still stored there, and there is no way to, in the iOS, to delete those pictures. And there are also stored the separate folder which stores all the pictures from your Twitter posts or from the posts you ever seen. There is stored also the last backup date and time, and there is a lot of information about Wi-Fi access points you are connected to, including the SSID, the signal strength, the security used there, and sometimes even the GPS coordinates. Here is a more advanced software. I won't say the name. That's not an advertisement, which explore the backup more deeper way and more advanced way, and extract everything it can from the backups, including the pictures from attachments. It can show the timeline, what the person, the owner, was ever doing there, and so on. That's not the only software. There is quite a few of them, and they're very convenient and very useful when you analyze the contents of the iOS device. In iOS 7, it was implemented a nice feature called frequent location. It is hidden very deep inside. You have to go to privacy settings, then to location services, then to system services, and there is a frequent locations. It is switched on by default, and it stores the database of the locations you ever visited, and it even writes down the exact time when you arrive to this location and when you leave it. You can see on those pictures, there is in the center there is a Moscow city, and at the top there is a 26 visit to my home, and the next line is my office. And the elsewhere line, it's the right one, is the other locations I ever been to. I don't know actually how how the size of this database is limited, or does it override the data or just keep it going. It isn't known actually. It isn't very well documented by Apple. And as you can see, for every location, it stores the exact date and time. And there is also an option called Improved Maps, which says that it actually sends the GPS locations of the places you ever visited to Apple, and it is said that it is implemented to improve the maps. But as you can see, it is, in fact, it is associated with your Apple ID, and so it is not as private as we want it to be. Also, in the iPhone 5S, there is a quite nice Touch ID feature to unlock your iPhone using your fingerprint instead of the passcode. And Apple says that this information never leaves the iPhone, and it's not stored in the backup, neither local nor iCloud backup. But unfortunately, we never know, and we cannot find, is it really so or not without the jailbreaking the iPhone. And at the moment, there is no jailbreak for iOS 7, and so we cannot say is it true or not. Probably you have heard about news. I think it has been revealed on Black Hat conference that someone found a way to hack into your iOS device when it just connected to the charger, and it was called like malicious charges or like that. You think that you are just charging your iPhone connected by your USB cable in the airport or in the restaurant and so on, but in fact, you connect not to the charger, but to the small computer which communicates to the iPhone using its own protocol. And what could be done, actually? The computer on the other side can perform the full backup of your iPhone to access your file system, many parts of it, and it can even install the application, any applications on your iPhone without your knowledge. There is only actually two things which protects you from that. First is the passcode. To be able to communicate with your iPhone, it should be unlocked. But usually when you connect to the charger, at one point you enter your passcode and so unlock it. And starting from this point, the software running on the other side can access all your data. And the second thing, which was implemented in iOS 7, there is a warning, and the iOS 7 is able to detect what is on the other side. Is it just a charger or it is a computer? And if it is a computer, it asks you whether to trust it or not, but most people usually answer yes. And I personally encountered that when I tried to connect my phone to the entertainment device on the transatlantic flight, and it had a USB port. It wasn't. I think that was not to insert your flash card to play the media cards, and was only for charging. But still, there was a computer on the other side, and so there is some risk. How it is being done? When you unlock your device connected to the computer, there are so-called pairing records created on both the device and the computer. And on an iOS device, it is stored in the library lockdown folder, and on Mac, you can find it in DB lockdown. There is, on the right side, there is a screenshot with all those pairing records. They're for the different iOS-based devices I ever connected to my home Mac. And what you can do if you have those parent records, You can actually talk to lockdown daemon, lockdown D, always running on the device. And you can connect to backup service and ask device to perform the backup and try it from the USB, start reading the data. You can access the software installation service, talk to it, and also ask to install the software on the device. You can get most of the device information, including device name, model, and everything, your phone number, your unique device ID, and so on. You can access the sync service to synchronize the data between the computer and the device. You can get the diagnostic information, various log files, and so on, and even install the device provisioning profiles, install them or delete them, and so on. And to get more information about that, about the pairing explored by some our security researcher, you can follow the links. And there is even a library, open source library, portable for different system called libmobile device, which you can use in your own applications to talk to the iPhone or iPad or iPod. And using this library, you can perform a so-called advanced logical acquisition. For jailbroken devices, you can get actually the complete contents of the device file system, even the locked files, which are usually not accessible to the applications running in the user mode. As I said, it can get all the device information, all the media files, and not only pictures and videos, but also books and even iTunes library, which don't go usually to the device, but only you can only keep the records of what music was there, or if you are not using the iMatch service. For the application data, you also get much more than for backups. You can also get the temporary files and cache folder, which is always there for all applications, and it contains a lot of interesting data. For example, the websites you access right from the application, and so on. All the messages, address book, keyboard cache I already mentioned. For SQLite databases, you can get the write-ahead logging files to see the transactions to the SQLite database, and so on. And so this kind of acquisition work even if the passcode is, even if the device is passcode locked. You only need to get the pair locking records from the computer, for example, from the seized computer. The other interesting point is that this kind of acquisition can be performed over Wi-Fi. The initial pairing should be performed through USB, but once you get those pairing, you can talk to the device through the USB or through Wi-Fi, and probably there is even a way to connect over the GSM network, but we never know. We haven't seen anybody doing that yet. And all you need to have, as I said, is a small single file from the computer. Now let's go to the iCloud. If the local backups are not accessible, you can work with iCloud backups. In both Windows and Mac systems, there is a very convenient iCloud control panel where you can set what data you are going to sync, and going to backups, you can see the list of the devices which has been ever backed up to the iCloud. You can see in my case there are 3. These are 2 iPhones. I'm not sure why 2. It should be only 1, and the iPad. But here in the control panel, you can only see the size of those backups, and if you wish, you can delete them, and that's it. You can just get them. And the only way to use the iCloud backup is to restore the device to it by just entering the Apple ID and password to it. So we have started to explore how is it going to work. What is the protocol used to backup and to restore the data? There is no way to backup to iCloud right from the iTunes. You can do that only from the device, and so it becomes much more tricky because you cannot debug the application working on the iPhone. So we get the jailbroken iPhone. We install to open SSH there, and we get the keychain out of the device. And we have, after deleting the iCloud account and resetting all the system, all the settings, so the restoring process should start. We have just replaced our certificates in the keychain, and so to be able to sniff the traffic between the iPhone and the iCloud services using basically any sniffer. And so the certificates used there to talk to the iCloud services, they're not pinned to the device, and so it was quite easy to perform like man-in-the-middle attack. Basically, what we have found is the locations are dynamic. You never know in advance where the data is stored, and endpoints depends on the Apple ID. The protocol is based on the Google protocol buffers, and all the files which go to the iCloud backup, they're split it into the chunks. These are portions of data of a variable size, and Apple provides a file to chunks mapping using a kind of XML files, and every chunk is encrypted using its own encryption key. And encryption key depends on the chunk data, and all the chunks stored not on in the Apple data centers, but on Amazon cloud and in Microsoft cloud. Here is a map how the files are actually stored in the iCloud. As I said, they are split into chunks. The reason for that is to avoid duplicates and to keep the data in the iCloud more compact, and also to make it easier to perform the incremental backups. When you first backup your iPhone into the iCloud, it actually takes quite a lot of time, maybe 2 or 3 hours, depending on the size of data. The next day, it uploads only the differences, so it's usually about 100, maybe 200 megabytes, and the third day, and then it's only 10 to 20 megabytes, for example, the updated SMS database. Here is a query to perform authentication in the iCloud to get access to backups. And it returns, obviously, the authentication token. And here is an example. Then there is also a series of queries to work with actually the backup, and there are different queries to get the exact location of the data of the next chunk, and another query to get the encryption keys used to decrypt this data. And to actually download files, there are also different queries to enumerate snapshots. Snapshots are so-called partial because only the first one is complete, and the next two are using only the differences of data. And then we get the file authentication tokens, which are different for all the files, and then we get the locations for the particular file chunks which are related to this file. And then that's probably the most interesting stuff. The previous query returns the location of the next file chunk, and from time to time we have seen both. Those are actual locations on the Microsoft and Amazon services. And at the moment, we don't know whether the backups are always stored on the both servers, or half of the backup goes to Microsoft and half of the backup goes to Amazon. I think there is a kind of redundancy there, and the backup is stored on both locations. Here is some technical stuff how the encryption is implemented in the iCloud. It also looks small, but once you'll get a copy of the presentation, you'll see it better. It is a little bit different in iOS versions 5 and 6 and then in iOS 7. The encryption is basically the same. It is AS256. And here is a routine which generates an initialization vector for IV for the encryption. It's not quite complex, and the encryption keys are always stored along with the data, as I said. So a kind of summary about the iCloud backup encryption. The data is stored on the third-party services, not on Apple services. The Apple has all the encryption keys to your data, and so if it gets a request from NSA or wherever, it can encrypt it and provide to third parties. Some data is encrypted additionally. For example, to decrypt the keychain, you have to get the keys which are related to your particular hardware, and it is never being sent to the Apple. And also, you cannot perform your own encryption on the data, and the data is only encrypted the way the Apple has implemented that. Next, about Find My Phone service, briefly because I don't have much time. You probably used it by entering your Apple ID and password. You get a list of all your devices and their locations. The protocol to access the Apple to get the locations is somehow similar to one used for backups. You also have to perform authentication and get the token, and then you have a query to get the current location of the device, but it will be not actually the current, but the one which is cached on the server. But by using the other request, you can ask the Apple service to refresh the location, and Apple sends the push notification to the device, and it returns its current location. But the device battery is being used very intensively when getting the GPS location, so don't use it too often. Here is an example from the demo application we have written, which accepts just the Apple ID and passwords, and get the list of all the devices and the exact location, the level of the battery, and the time when it has been last seen in the network. The Apple iCloud stores not only the backups and the location of your data, but also the documents from the iWork package. And to get the files from the iCloud, you also have to perform all the steps like I mentioned for backups and the location ID. There is a series of queries, the post queries with also Apple ID and data, and you get the authentication token in return, and then in return we get the list of all the files stored in the iCloud. And basically through iCloud control panel, you can only get the iWork documents, which are keynotes, keynote pages and numbers. But using the specific queries sent to the iCloud, you can also get the other data from there, from the data for the applications which are using the iCloud as well. And for iWork application, we have found that in iCloud, there is not those data is stored not in native Apple format, but you can just get the map like an XML files, and the text is stored in the SQLite database, and the pictures are stored separately. And there are special commands to request these documents in native Apple format, or in Microsoft compatible format, or in PDF. This is also an output from the demo application which shows the list of the documents stored there. You can see that this Apple Pages file, but it is split into many different files. Quickly about Apple two-factor authentication. It is actually good and makes your experience with Apple account much more secure. But the problem is that it only protects only your Apple ID site and basically your credit card. But it does not protect access to your backups stored there, to your documents, and to your location. About ISO and iCloud keychain, that's probably the most interesting part. You can ask the iOS to synchronize your data from the keychain, which are basically the passwords, credit card data, and so on, to be stored in the iCloud, and you're able to sync it between all your Apple devices, which are iPhone, iPad, and Mac. And you have to set the security code, which is 4 digits only, and you have to set the like a security password, which is used for recovery. Usually, you can get access to the keychain but only by asking the Apple to send the verification code to one of your trusted devices, for example, for iPhone. And you receive the SMS message from the Apple, and you have to enter it to get access to the keychain. And once you set up the iCloud keychain, you have in the keychain access utility, you have a new database which stores all your iCloud. This keychain is actually cached on your device. I'll skip that. Okay, yeah, here is set up. And once I connect from my Mac to the iCloud, I have to enter the recovery code. We have investigated a little bit the protocol used there and found there is quite a lot of components in the operating system that interacts with iCloud. These are several daemons running on the Mac operating system. Obviously, it was much easier to explore the code running on the Mac rather than on the iOS device. There is a driver which works with local storage on the key change, and there are daemons which communicate with each other to get the data from Apple, to encrypt the queries and being sent there, to decrypt the responses, and to store the information in the local database. Here is basically a map how it works. Also, sorry for small text. Interaction between the daemons running on the Mac and the components running on the Apple side. And here is a sequence of sync query. The Apple keychain is stored as any other data in the Apple iCloud. Basically, you can read the information about the iCloud storage in the Apple website in the knowledge base about the same way. But the information stored there is encrypted with the keyback, which is a collection of the keys. The keyback itself is encrypted with its own encryption key. And to get access to this encryption key, to be able to decrypt it and so decrypt all the chain, you have to enter your security password, which you set up, the recovery password, which you set up on the first step. And here is a query, actually 2 queries, no, just one, to get the keychain. And by using the different parameters with the next query of the same time, you get the keyback. And once you got the keychain and keyback, you only need to get the decryption key. And here is the query to get the keyback key, the key which is used to encrypt and decrypt the keyback and so get access to the data. There are 2 requests there. One is the srp init, and it returns some binary data which you have to insert to the next query called recover, and then it returns the keyback key. And once you got it, it is being cached locally in your operating system. So next time when you start it, you don't need to enter the recovery password to get access to the keychain. So the conclusion about the Apple iCloud. There's obviously a balance between the convenience, privacy, and security. You can get only 2 of the 3. And if it will be very secure, it will be very convenient. But you have to understand the security risk because, as said, the information stored there in iCloud, it is accessible to anyone who has your Apple ID and password, which this information is usually secure, but there is quite a lot of social engineering methods to get it, and there is also a problem of password reuse. And 2-factor authentication obviously don't protect your data. It requires still a lot of work from our sides, mostly on the iCloud keychain. We have reconstructed a lot of queries, but we still don't know exactly yet whether Apple and so all the law enforcement or whoever has access to your data. Probably they do, because for the other authentication with the code, 4-digit codes sent to the device, there is not quite a lot of combinations to check. It's only 4 digits, so only 10,000. And so probably there is a chance for kind of offline attack to try all those combinations and so get complete access. But once you understand all those risks, that's up to you to use the iCloud services or not. Okay, thank you.
Thank you. Are there any questions?
Okay, thanks again. I will share a copy of this presentation, and if you need any explanations or whatever, you can catch me over there. Okay, thanks.
Thank you.